Yeah, thank you.
Hello, everyone. My name is Vitaliy Gdulya. I'm Chief Platform Officer at Creatio. And today, Andrew Lazariev, QA Technical Leader, and me will share with you some experience and interesting insights about releasing big enterprise products. But before we start, I would like to briefly describe our company. So Creatio is a software vendor that builds enterprise agentic automation platform, and on top of this platform delivers numerous business applications, full CRM bundle of applications, different industrial solutions, and a marketplace where independent software vendors create their own applications and products on top of Creatio platform. So we are a company of around 9,500 people. We operate globally, and our employees are located more than in 25 countries currently. And we rely on our huge partner network that currently has over 500 organizations, and that allows us to deliver our products to enterprises in more than 100 countries all over the world and for thousands and thousands of users. So you can imagine that releasing the platform and this number of products where you need to combine into some stable and reliable result the work of more than 25, if I'm not mistaken, 30 Scrum teams, it may be a challenge. So today we are going to tell you how we overcome that and what lessons we learn during that process.
Yeah, basically, as we are enterprise, we're like have a huge number of teams, a huge number of products, and especially a huge number of tests. I mean, like more than 16,000 end-to-end tests, more than like 20,000 API tests, unit tests, integration, a lot of the network across the 3 departments, that like more than 30 teams, and especially they have their unique workflows, because we like to decide team how to work, how to bring the product. And as we are like enterprise in releasing the product, we're releasing like in a simple point, but this means that we are combining the workflows, combining the pieces of product in one big like application. Like some of them using kind of microservices in one way, some another. They're having like some have the multi-tenant architecture, some not. And the simple thing that we are synchronizing in releases in one point with a lot of teams, with a lot of type of functionality in like one point. And we have a like simple question. So how is the release? Basically, which means that we have to synchronize over a lot of manual offline tools, Jira tickets and bug tracking, some kind of conversation over the chat in Microsoft Teams. So basically that a lot of chaos inside. And we like spending like just a couple of days, like 1, maybe 2, maybe 3 days, just to have the answer. What is the status of the release? Can we release it now, or we should postpone it tomorrow or in the next week? We don't know. So basically, this is a lot of mono work, a lot of human work. So we decided to make the application that will synchronize everything, like Jiras, chats, CIs, like from TeamCity, Jenkins, and so on, the builds, and have the correct answer, what is the status of release. So basically, we decided to make our own application. And yeah, of course, we try to focus on the market, focusing to see what market have for this purpose, for this solution. And sometimes it worked good, sometimes bad, but basically we decided that we want to full control of this application. We wanted to extend any time in every type of workflow we want. We have like, we don't want to like vendor locking or something, customizing that we're locking and so on. So basically we would just bring another process over the process. So the idea was like to build the applications with the AI agents that will analyze everything. I mean like the successful runs of the builds, of the tests, the analysis of the tests, the tracking, recognition, patterns, and so on. Everything that quality assurance department do, everything like every team do, developers, product owners, they just want to know the information, how it is, what is the status, are we good or not? So, yeah. And the solution is like pretty obvious. So we have a lot of teams that is always growing just because we're hiring. They like kind of a lot of revisions, manual checks, analysis. We want to combine this analysis over analysis from cross teams communications. And that means that we have to release in one day, in one run, a lot of products in a like single way to release to the market, to our customers over a lot of countries in the world. And of course, we want it in like quality way. So basically we just get the challenge to us to bring this formula, get the analysis and the statuses from 3 days of accommodation for everything to one click in one instant overview that we have a report about everything. Do we have bugs or not? What is the status and things like that. So we built application. It's a pretty simple web application or not simple, I don't know. And we name it Symmetry, like CI and the metrics. And it has like 3 major workflows with the full regression test about the all regressions in all testing levels, test success rate to see the patterns recognition, historical trend to catch the floating errors, floating bugs that it cannot be catchable. So we have a lot of these informations, like thousands of lines of logs that should be analyzed somehow. And of course, release workflow functionality that would get us to this correct information that we need to. So that's about the release tracking and who is using this application. Not just the QA engineers, not just the developers, but another team leaders, I mean like product leaders maybe, developers, release managers, and everyone who involved in the process of creating functionality to the customer, I mean. Yeah. So, but how it works? That's the application based on the microservice architecture like Symmetry, and we have a lot of extensions, some kind of which are fetching the data from our sources and especially from the CI, from Jenkins or TeamCity, that we have information about the builds, assemblies, cores, testing, all of the stages and things like that. So we have this information, we're fetching this data and bringing to the LLM integration service that have dynamic agents, vector database to have the similarities, pattern matching. And of course, we have LLM models to any type of use. It could be a local using Ollama, or it could be like any enterprise model. So that's just like the options that could be used. And as a result, after the LLM had this analysis over everything that we want to analyze, we have just a simple report with the brief information about the status, about the functionality, about what is going on and what we should do next, because we have not just like a simple report that it is, but the actions also in this report, just to know what to do, in what direction do we have to go. Yeah. And inside of it, so if we deep in dive to the LLM service, we have these functionalities inside of it that basically solve the pretty particular problems. Like, for example, when something like failed, you are going to the log, seeing 100 of lines, but the answer is on the like line number 375, and you just write it down, trying to use the LLM, maybe trying to use another approaches, but this service just goes to the correct order, in the correct order, in correct place, and just signaling you the error is here, the pattern recognition here, and what we should do next. The error clustering, so we are grouping similar errors, so we're bringing information over the cross-team functionality and getting the information that the exact bug is not here. The exact reason of this bug is over the another place. So we just get this information. We have a semantic search, team-based statistics to get learning with our history, with our historical data, because something that starts to happen in the wrong way, maybe that it starts 2 weeks ago, 3 weeks ago, we just didn't analyze that. And now we do have this information because we have a lot of the integration with MCP also. We're analyzing the code bases, commits, and so on, that go now to prevent the errors or the group of analysis, and that's it. And of course, pattern recognitions to catch as much as we can the floating errors that cannot be catched in a like simple way. It is hard to reproduce somehow. Yes.
And what is even more important is that this helps teams to effectively collaborate, because this all that Andrew describes works for multiple teams. And basically one of the challenges is that when you allow multiple teams to work on the same code base and you do not limit them in that, you never know when one team suddenly somehow affects functionality or the dependency of the other team. So having this centralized view really helps people to be much more effective in understanding what's going on overall with the product and the release.
Yeah, of course. But let's dive more deeply. So about the dynamic engine informations. But before I start to explain it, there is a simple, example. There is no reason to use the general AI agent to everything. It never work, because there always the situation that is not similar to other situations. So we decided somehow to build the AI agent that would analyze the particular type of problem every time he faces it. And the challenge is that we have to build a lot of agents, then we have to decide what agent should be used. And this is kind of the issue. So we, inside of the LLM service, build the service that is combining a lot of system prompts, instructions, and the settings, and we have a meta agent orchestrator that decide what type of agent should be combined in one agent and give him a task to analyze. You have information about the domain-specific something, output format that should be usable, what we are analyzing, backend or front-end, or we maybe have some performance problems, issues with infrastructure or some kind of information that we cannot catch. And of course, adding the necessary MCP tools. It's pretty common, like Contact Simon about documentation, Jira, Git, and so on. That would be much useful, not just to catch the issue, but recognize the a chain of this issue that were happened. So this meta agent is getting the all the information needed, constructing the agent, and then give him a task. Unfortunately, we have a presentation that here it's cut. Yeah, thank you very much. So after the final agent assembled, we are giving him a task to analyze, and of course, could be a lot of multiple agents. And the pipeline started to run within parallel using a lot of particular agents for each type of issue, of each type of task. And then when we do have all the information from the agents, we're summarizing report to user with the pattern recognition, grouping similarities, and so basically in a final output, we have like a lot, like 2-line or maybe 3-line summary report, the patterns, related Jira issues that causes to that these things come from here, from this sprint, from this like story or the task or the maybe bug fixing, and something that it could be recognized more like everyone who is like controlling or trying to understand what is happening now with the kind of particular functionality in the release or like in the product. So next in the slide, that's a screenshot from the application. Basically, that's the example what kind of report do we have. So basically we have like number, the name of teams, name of functionality, how much that it failed, possible cause, recommendation, and that's it. The information that basically a lot of engineers spending a lot of time, but we do have like in the morning, for example, a lot of the information that is caused from the release, of course. And I like, as I mentioned earlier, we have like a lot of a huge thousand of end-to-end tests, API tests, unit tests that should be analyzed. And sometimes it brings a lot of time to understand what is going on, but we cannot hold. We should like delivering the product, delivering features, and this causes to analyze, and we have all the information like in the basic summary, root cause analysis, failure trends, and so on. That's the another screenshot from the application. Like it depends for the manager, like to see how much product is ready from tests, how much teams are ready.
That is my favorite part, basically. So really, the level of transparency, level of clarity, and the speed that any team and any engineering department member can react to what's going on and understand what's going on is very impressive. And well, we will talk about the numbers in details, but my subjective feeling about that is that we have like 100% better release process than we used to have without tools like this.
Yeah, thank you, Vitaliy. Yeah. So what about the import before and after? So basically, we reduce a lot of things that could be reduced. So basically, the release status takes from 3 days to 1 click, like 10 minutes maybe, or 5. So the monitoring, morning analysis, like every day we're spending like about the hour to analyze, and then we have like 10 minutes to wait to analyze everything and get the informations, actions, similarities, like issues, links, and so on. Pattern recognition is fully automatic. We don't need to communicate a lot to each other, like asking the simple question, I see this, who can help me to handle this, and so on. So the release tracking is pretty transparent. So it has updates in real time. We don't need to analyze them. Sometimes, everyone uses in the releases some kind of Excels, some kind of tables that is like fully offline and not connected to other tracking systems. And of course, the root cause from hours to minutes. So that's the impacts we measure. And I think we are pretty obvious say that we reduce from 3 days to 1 click. This report. That's a huge report, have to read, okay? But it's very quick, very precise, and we're upgrading every time this functionality. But the major thing that we have to tell you today is not about what the application does, how we provide it and focused to upgrade our processes to make it more transparent, more quicker, more precise, but about how this application were developed. Because this application inside our company were developed by two people who are not developers, only using the AI agentic workflows, especially this application were developed by me and Helena Coffin, she's sitting right there. Yeah, so we basically start with the idea, what if we can? What if we build everything that our head, that everything we have to upgrade or maybe solve, because there was a lot of time with a lot of meetings, how we can just fix something to make it faster, make it transparent and things so on. We didn't get the solution. And in some day we just get the, try to develop something that would help us. And then it started to help the company. I mean, for a lot of the team, we have a lot of good feedback. We have a bad feedback too, but a lot of good feedback from this application. So basically we started to work with build not the application, but the AI workflow to develop this application. So there is three streams for development. Firstly, the main agents. It's pretty simple. Everyone who started using with the coding agent, just using some tool like Clock Code, Codex, or Copilot, something else, and we have one agent that doing something, coding, analyzing, spouting subagents, and so on, and that's it. But we face it with a lot of error because we're not developers. We don't know about the proper architecture, proper design, and something else. So we need someone or something that will double check our results, because we just develop something, for example, make this functionality and make no mistakes. That's not working, but everyone tried it. Yeah, that's funny, but we decided that we have to make another agents that were working in a parallel way and making the feedback loop. Basically, it's work one agent is developing something or the planning agent, and the another agent is checking the result of this agent and correcting the agents. And the major reason why it's happening, why we decided to use it to do this, because to reduce a lot of hallucinations of any LLM models. I think you face enough already with this. So going deeply with the planning stage. So we are getting the information from the Jira when we just describe it, the feature we want, the bug we want to fix, or the architecture we need to some kind of a lot of performance that we have to reach. And the planning agents in the main agents loop is just analyzing code base, implementation steps, and the simple thing, there is nothing new here. But in the meantime, in a parallel way, the planning reviewer is reviewing this. So the major job for this agent is to check the results of these agents and check the overall expectation that were from this Jira task or I don't know, the prompt that you were used. And only after then we have the plan approved by human, by me or Helena, and we're just reading the things that sometimes we cannot understand, sometimes we don't, but we are checking the goals, the vision, maybe build some kind of a lot of prototypes and so on. And then in the next stage, it starts the implementation stage. After the approved plan, the main agents start to write source code, writing the test, integration test, and so on, updating documentation, of course. And in another stream, there is another agent with another instructions, with another proposals and connections that is online, in a parallel way, checking step by step the plan implementation. If the main agents goes wrong in a wrong direction, it could reject or approved again and bring back the main agents to the main source. And then we have something that looks like a quality code that could be measured, and when we can install it to the testing stage and go run the tests that we know, because for this application we have own pipelines with own tests, with own unit coverage, without end-to-end testing, performance testing, and so on, of course. Yeah, so the infrastructure that we developed to develop the applications that I described before with more than 90 agents. There's a unique specialized agents, of course. The custom commands, someone called it like prompts or something else, a lot of this, that are used by the agents or the sub-agents in the parallel also. Hooks, this is very important point, especially the hook on the error, which means that when one agent is working and second agent is working, it happens sometimes that it falls to error. Like, it just doesn't work. Not just because, but like, I don't know, internet is like going down and then goes back and something else. And another agent should see the errors and bring back to work all other sub-agents, like just type in some pretty similar commands like retry or something else, or bring it back, step back forward, and again.
You can basically do it manually, but Andrew prefers to sleep while agents are working.
Yeah. So I just started
Andrew, maybe you should describe how basically the life cycle of the task looks.
Yeah.
So when you have some incoming request from one of QAs from the teams, what happens?
That's the good example, like from a real life, like maybe 2 days ago or 3 days ago. So basically, the workflow and the lifetime cycle is like in the morning, some engineer requesting a feature, and by the end of the day, I would say to 4 p.m. this feature is implemented on the production. So basically, we have the feature requests, somehow describe it. We're starting the agents, it develops, going through all the workflows from the planning stages, implementation stages, that's next to the testing stage application, running all the tests, and then just deploying this feature that were requested from the user. So mainly this like a half of day. We have a small features or maybe medium features to be implemented already. Or another type of way, so I am starting something to develop with idea, with implementation, and then I just start in all the agents and workflows and go to sleep. And I wake up on the morning and I see that something is being developed and it's working. And for now, is like a success rate of the starting agents is like about 75%. So 75 times, like 3 times in the 4, I have successfully implemented the feature, fixed the bug, fixed the architecture, and so on. Something is failing just because, but every day we are improving our agent workflow, adding new agents, like reading some kind of documentations, maybe are just seeing like someone doing in another way, and we are like upgrading our workflows to do it better and better every day. Of course.
And when Andrew says we, he means he and his colleague, who are not developers. So like everything that you see on the screen is built by 2 our QA tech leads.
Yeah, so answering the first question that we started in this presentation, how many agents do we need? We don't know how many agents. It's always raising, but for now we have more than 37 total like components. Some of them are agents, MCP integrations, plugin, orchestrators that are also agents. So for now, with like 37 unique components, agents and hooks and something else that is working in the symmetry, in the level of production of symmetry, analyzing all the things that around of this workflow and the release, of course. I mean, like releasing products in the company because we're heading all this way. So I would simply will summarize the key principles that could be used by any type of tool, any type of AI workflow, any type of language model. It doesn't matter, basically. So the multiple streams is more effective than the single stream, like you're using in a single way. So the like planning and code reviewing is also important. The parallel execution, it like I know that a lot of teams and a lot of companies that is using the AI workflows trying to reach the goal with the speeding up the process of production. But the key is not about to make it more faster. The key, I think, is about the parallelizing the task. So basically, you can do 3 or 4 features in a like one stream and just catch the results from the agents, synthetic reports, and that's it. Unique specialization, yeah. One agent, one responsibility, no common responsibility about everything at all. It doesn't work, unfortunately. Yeah.
And basically, talking about these specialized agents, important thing is that some of them are dedicated to some type of task, and basically they can be reused in different applications, and we are even thinking of open sourcing part of this functionality. But some of them, and you need to be ready for that, are dedicated to a specific application that we are developing. So they can be used and can effectively help to develop only this application. But if we are talking about some applications where you believe the life cycle will be long, you will have to support them for some significant time, that totally makes sense. Don't be afraid to create these really sharply focused agents that in the end will help you to that will be able to understand the specifics of that task you are solving at this exact moment of time.
Yeah, of course. Yeah, let's talk about the simple conclusions. So basically, complex products can be built with AI agents. It doesn't mean that it cannot. Yeah, that's a lot of level of complexity, but you know that technology is growing up every day more and more, so that's it. And it could be built with the non-developers, but with the proper agent architecture. So you have to should start to understand the architecture. How does LLM works? What could be built? What could be combined in this way? And it could lead to the working product serving to real users that are just don't need to deep dive in the application, just using this functionality for their purposes and so on. And the multiple agents should be work as a team in the parallel executions to ensure in the first way the quality of the increment of each execution they are made for. So the keys inside. So it's not about the AI replacing the developers. Yeah, just because we're not developers. It's about the human orchestrating the AI agents. Yeah, that's the thing. I think the developers could do more effective impact with it comparing to the non-developers, I think. But yeah, that's the reason, and that's the side we have in this development workflow.
Yeah, and for me, this is a really inspiring example of how modern approaches, modern technologies can completely change the way how we work on absolutely different tasks. On tasks of releasing products, on tasks of building some custom solutions for us, on tasks for developing some utilities and increasing productivity of our internal team members or other people in the company. And I encourage you to not be afraid of testing and frankly saying this rapidly evolving industry and set of technologies and tools can allow anyone to become a developer.
Yeah, thank you very much. Thank you, everyone.